Welcome our three panelists, Deanna Shields, Imad Pasha, and David Suko. We had a wonderful discussion about content that we'll try to maybe bring some of in to our discussion today. Maybe we should start by first telling everyone each where you teach and what your 2-sentence summary.
Hello, I'm Deanna Shields. I teach at the University of Arkansas. I teach big, giant survey courses, and sometimes I coordinate and develop the lab as well, although the lab is a separate course. I also teach Physics and Human Affairs, which is a large survey physics course with no math at all. And occasionally they let me teach an advanced class like modern physics.
Hello, my name is Imad. I teach at Yale University, and primarily my focus has been on upper level research methods kinds of courses for majors, particularly on the programming side of things, but I've also been a part of the administration of larger classes as well.
Hi, I'm David Suko. I teach at Washington and Lee University. It's a fancy, small liberal arts college about 3 hours up the road, also a shrine to the Confederacy. Just got to put that out there. That's the Lee we're talking about. What can I tell you? In any case, I am a laser physicist by training, recently become an astronomer, and I normally will teach an intro astro course and have started tinkering with some intermediate electives for physics majors.
Wonderful. Thank you all so much for being here. Our first question is about what content we most hope students will take with them after our course ends and what content we think they actually do take with them after our course ends. So how many of us teach in our classes the inverse square law in some flavor thereof? And for how many of you who just raised your hands after the course ends, what percentage of your students would be likely to take Jupiter's distance of 5 times Earth's from the sun as an indication that it gets 1/25 of the energy per area? Have a few hands? Some might, some maybe do. So then the question is, how important is that to us? How much of a learning goal is that? Should that be? How fundamental is it for us? And giving that as kind of a framework, there's probably a lot of content like that that is similarly slippery out of their minds after the course ends. So I'll turn it over to our panelists and see any thoughts, observations, anecdotes to share about what content you hope students take with them.
Well, I'm going to jump to the second part. What students in my class really want is to look through a telescope on those particularly cloudy semesters when our night lab gets rained out and then the alternate also get rained out. I hear about it on the course evals. They want to see through a telescope. And they don't believe what they see when they see it. They're like, Saturn looks fake.
My first semester at Yale was TFing for a class that was taught by Greg Laughlin, and one of the questions on his final really inspired me, which was, how many trees are there in Connecticut? And I think the thing I really liked about that is that walking around and seeing students trying to Google it on their phones was entertaining before I took away the phones. But second of all, I think it really got at the core of what his particular course was about, which was Earth in its cosmic context. And there was a lot of these kinds of reasoning questions throughout the class that were related to astronomy. And then the final kind of like brought it back around and showed that you can use that kind of sort of order of magnitude estimation, look out the window, how many trees do you see? Okay, can I extrapolate? That kind of thing sort of back to their everyday experience. And so my answer to coming back to the first part of the question would really be, I hope they take away the ability to think like that more than any particular thing that I may have covered, like the inverse square law.
Right. And Dan has already said content doesn't matter. Is that what I recall you saying, Dan? Content doesn't matter. So my flavor of content doesn't matter is that any particular fact or concept isn't particularly important. What I'm interested in is what I hope the students will take with them is something of a big picture, right? How does the content fit with the methodology and the inferences and the context? So all of that to me is content that you need so that you can build the big picture. So I say I think every piece of that is like a pixel. And I want the students to get enough pixels to at least get a grainy picture, and the more content they can absorb, then the better their high-res picture gets. That's kind of how I think about it. I was thinking about our other conversation earlier about what inspires and motivates the students to, and the way I kind of think about that is asking, my secret agenda in the class is for each student to develop a personal relationship with the night sky. And that can look really different for every student, but it gives them a reason to care. It gives them a reason to be interested in light pollution or learning more. And it takes some time and reflection, and I do it without telling them. What do I think they remember? I hope they remember the basic recipe, which is observe light, apply physics, learn something about astronomy. I think that message maybe gets through. The other thing they get are the visual impressions. I think that they can walk away and start looking at pictures and say, I think I know what that object is. I think I know why it's pink. I think I know why, whether it's at the beginning or the end of a star's life.
Oh, yeah, really great. I think looking at the night sky seems like a theme that emerges for many of us and for many of our students, having that experience. Oh, I'm sorry. I think I have one, but maybe I'm not talking into it. How about I move this up a little bit or something? But yeah, I have them look at Delta Sep. It's our class pet star. That was Enrique Gomez's idea. I don't know if you remember giving me that idea, but it's been a fixture of my classes ever since. And I always feel like if they can sometime after my course ends go out and still find it, then like I win. But I don't know if they can. I've never asked that question. Any other thoughts on content or essential content or content you think sticks or that you hope will stick? It's the after lunch effect. Yeah.
Sorry, just want to jump in. Does film actually be working? And just make sure you don't hold it up to your face. They work better when they're a little down, so it amplifies your voice. And otherwise, feel free to throw them around and kind of talking to them.
Okay. There it is.
There we go.
Hold it like a baby.
One of the things I struggle with, I don't teach it in astronomy, but physics, is that there are many different students in a class, and what they take away is different. So it's not one size fits all. And identifying the different elements.
You can have my mic. So if I heard, if I can paraphrase, if I heard correctly, the struggle is the difference in students and the content that they find meaningful?
Yeah, and they have
Different needs, different needs and different takes on it. So they maybe all take away something different, which comes back to the content doesn't matter point. Any other thoughts before we, on our blistering pace? Yes. So they take images and then they have the images and they bring those from the class. Yes. Yeah. So the ownership piece. Nice.
I think a similar thing is true at the upper levels where whether it's really coding focused or only partially, when students have written something that can actually perform an analysis of some kind, I often hear that later when they were doing one of their first or second research projects, they ended up going back to that code and building on it, or at least referencing it in the future. And I think part of how we look at the different levels that different students come in and leave every class with is, I feel like if students have walked away at least with something that they can go back to, even if they didn't get it the first time around. You always have to kind of see things multiple times to really ingest them. And so having something concrete that they can look back at, I think is really valuable.
Oh, that's such a good point. Like something that they've created or, designed or coded or what.
As somebody who teaches a lot of lab courses, like one of the things I have my students do is do research, and they have to do research posters at the end of the semester. And so there's many times they actually have said, oh my gosh, I totally know how to use Excel now, or I know how to use PowerPoint now, or like much, much better. And in the end, they get to kind of choose what they do, but we've led them through a lot of different ways of asking questions and how you ask questions and these are non-science majors. And so it's really fascinating to see what they want to do, but they also love going out observing. That's one of the things we do in astronomy lab is we go out and look at stuff, but we only do it 3 times during the semester. And because they're like then still happy, otherwise it's twiddling with telescopes. And they don't want to do that every single time. They want to do something more.
Well, can I ask, is Excel part, is that like in the learning goals in your syllabus, or is that
No.
an incidental
They
thing?
have to analyze the data that they get, and they get it from freely available internet sources, and they figure out that Excel is one of the best ways, or Sheets, right?
Something,
some sort
yeah,
of program.
spreadsheets in
Yeah,
general.
to make a visualization. They have to make a visualization eventually.
So yeah, that's a really interesting point in itself and plays into what I think Ken mentioned a lot earlier in the previous discussion about like ability to generate and read and interpret a graph, right? Maybe it's not in our syllabi, or maybe it is, but it's something we all care about, right? And that's kind of could be any content, once again. Shall we move on, or do we have more thoughts on?
I have one more thing. Students don't like the fact that I feel like one of my jobs in astronomy is to catch them up on very basic math, because many of them despise math, and I want to meet them where they are. So we do a lot of examples in class, and in particular, I want to teach them how to use a calculator. When I was a kid, using a calculator was lazy. That is not the case now. It is a skill unto itself, and it's a skill that many non-science majors and some science majors haven't developed yet, and it's a useful one.
That's a really good point too. And I noticed you mentioned that your students push back on that a bit, and as do mine. And then the question is like, even if they don't, if we think they need it, then even if they don't want it, where do we find that balance, right? That's probably another one with a different answer for every audience slash teacher slash situation.
I wonder if that comment extends to like writing code for ChatGPT. Or we just want to use calculators now as a skill.
Usually pretty loud, but so it's all everywhere. I was just about to raise my hand to make that point. It's not just a calculator, although Deanna, your point was well made about that. It's about using the technology because they're using it now. And the question is, we have to basically, incorporate that and, teach them how to question it because it's here to stay. Everybody's using it, And that's absolutely right. And it kind of goes back to the content question. I'll reemphasize, I think one of the points that's made is that as far as taking away the content from the end of the course, again, for me, I'm not sure that matters much. Content is a way to achieve the goals of the course, right? I'm more concerned that they get the goals of the course, like with scientific thinking and all that. Then if we do that by teaching phases, I know that's not what we're doing here, right? That's the point. But then teach the phases even if they don't remember it, but if they remember the goals, right? So, I mean, and I'll shut up now. How's that?
Did you have another?
Hello, can I interject something?
I'm sorry.
ChatGPT is new, but pipelines for data reduction are very old. And one of the things that we have to do with ChatGPT, or with what we should have done 20 years ago. I come from a side of astronomy that may be a bit, maybe it's controversial to a lot of you. We don't go to telescopes anymore. Everything is coming downloaded in a data packet. Maybe it's a ground-based telescope, but it's coming from Chandra or HST or JBST or Spitzer or what have you. And all of this data has been pre-processed by some black box, comes to the user, and the user then manipulates it in order to do some science. And that whole pipeline is completely obscured unless you really care about the science that you're doing. And that's the same thing that ChatGPT does. You have to train them where ChatGPT fails. I can't tell you how many times I've been to a AAS meeting and someone has no idea what dark current is. Like, you have to teach in an astronomy at an undergraduate level, this is the CCD equation, and these are sources of noise, whether it's in the radio or optical or whatever, but you have to teach that, and they have to come away with that, because if they don't, they're going to make mistakes later down the road because they've never seen how the sausage is made. The other thing that I'd like to say is, on the conspiracy theory, the students have to walk out of my class knowing, I tell them at the last lecture is all, I say very well, the universe is 13.8 billion years old. And how do I know this? This is not just something that I believe in the sense that we use the word believe in the common parlance. I can demonstrate this to you. And I say, we're going to do a derivation that you can prove to your grandmother the universe is 13.8 billion years old, give or take, a couple 100 million, but good enough for astronomical work. And the conspiracy theorists who come in and say, well, how do we know the Earth is not orbiting by the sun, but in fact the sun does? You have to walk out with that information, is in the 101 level or at the graduate or undergraduate. You have to see how the sausage is made, because people don't go to I'm young. I'm still young. But I think I was the last generation that in graduate school spent a significant amount of time at a ground-based telescope, but works primarily with HST or James Webb. And I think that generation is, unfortunately disappearing very quickly, unless they're studying Milky Way objects. But we're not going to redshift 15 objects, except for with HALMA, but no one goes to 28,000 feet or wherever HALMA is. You're getting a pipeline-reduced product that then you then manipulate to produce your paper. So that's one of the things they have to walk away with, is how the sausage is made.
Also a great question. How the sausage is made. The survey for AstroEdUNC, I don't even teach them dark bias flat reduction. We rely on the automated product so they can get straight to the science in the time that's allocated. But of course, with the higher level, you're going to want to get into noise equations, et cetera, so they understand it. You got to figure out where that level is.
Brought up ChatGPT because I was so sad that question ended up way down on the list when everyone ranked it. I wanted that nearer the top, but it certainly illustrates some of the pitfalls when you don't know how to evaluate what it's saying and you trust, right? And it's impossible to know all the things you need to know sometimes in order to be able to decide whether what it's telling you is accurate, which is a problem that I struggle with, like using it for myself, let alone thinking about students using it. So that's, yeah, no answers there, just more questions. But not that I'm competitive, but they got through 4 in the last one, so I'm gonna move us on.
One up, so you got us 5.
Oh, 5, all right, we're moving on. And so then the second one here,
How do you know?
how do you know? Yes. How do we know what we know? Yes. So if we move toward investigation-driven approaches, what content are we getting rid of? Like if we find inverse square law fundamental, you could do a Jupiter colonization project investigation where they will never forget, right, that it receives 1/25th of the light Earth receives per area from the sun. Will they be able to extend that to other objects that are at different distances from the sun? Having taught astrobiology, I'm going to go ahead and say no. So then how is that valuable, or is that still valuable given that they'll remember that because they created it? And so, yeah, again, not a lot of answers, but a lot of questions. So I'll turn it to our panelists for their hot takes.
Yeah, I mean, so we were discussing this a little bit at lunch as well, and I think it depends a little bit, going back to your point about how important the content is. And so when you are talking about the Bedrock Research Methods course that's going to drive how students approach actual astrophysical research moving forward, you have a lot of content that you have to cover. And the thing that we were sort of discussing is how in a traditional lecture-based course, very often students are not processing the information very much during the lecture, they're just writing it down. But then they're expected to take time on their own in the evening. There's a certain number of hours that are going to be spent processing the information as they try to do their problem sets or whatever it may be. And when you move to primarily investigation-based things in the classroom, you take that processing time and move it into a time where you were otherwise covering content. And so just definitionally, there's less content. And so I think this effect is much worse when you have, you know, the astro majors have to learn these 10 things, otherwise we're doing them a disservice, versus perhaps in different classes with different goals, particularly non-majors classes, maybe we are less concerned that they remember a specific factoid, and so they're, you know, focusing on investigations may be better, but you are always giving something up time-wise in that way.
Maybe just to follow on that, though, I think the fear of leaving traditional, so to speak, methods is that it goes more slowly. Eat the mic. Oh, yeah. Hi there, everyone. Yeah, I think the fear is that we won't cover as much. If we, and I think the delusion is that they're retaining what we cover. So when I think about this, I think we probably don't lose a lot of content, but I do think we organize it differently. You know, textbooks, lectures build something from the ground up. It's a logical and coherent structure. And research and projects are much more chaotic, and you run into problems and then you solve them, and then you run into new problems and you solve them. And so I'm a big fan of the idea that it's most important to the students when it's immediately apparent that they need to know it. So it's kind of the just-in-time teaching model, right? It's that idea that you start with a project, and so what do? You know, Daryl, where you want to do star clusters? You know, maybe we think, okay, let's get empirical. What kind of clusters are there? How bright are they? Are they? Where would we look in the sky? And once you know that, maybe you get interested in how would we measure them? What colors are them? How do I do photometry? And then maybe once you've got some data, then you can start asking intelligent questions about what does it mean and what can we infer from it? And you know, that it means you cover all of the content in the context of an investigation. So that's, you know, that's my take.
This semester, or the previous semester in my survey course, I tried to implement more group activities, which I think worked in terms of students learning more. I haven't done the computations yet, but I think they learn more. They seem to learn more. But the problem is we did slow the pace of the class, and it meant that we didn't get through the end of the book. So what was chopped off was the end of the book, which was cosmology. I hate that. I want them to learn cosmology. Moreover, it's in the catalog, so if the administration got wind of that, they would tell me about it. I'm thinking of ways to compensate for that, and I think of two ways. The cheap way is to do some sort of model, some sort of optional modules that they can do at the end and just say, okay, if you want to learn cosmology, here it is, but you're not going to be assessed on it. The harder way, and the way that I really want to dig into, is to be more surgical. Just with each chapter, figure out precisely what we want to learn, cut the fat, but that takes a lot of time. Of course, teaching takes a lot of time, and we have to figure out how much we have.
So on that issue, we were told that same stuff's come up with us. We need to cut stuff out, and they go, you can't cut stuff out. I mean, time-wise. And so they've told us, make your course hybrid. And that is the administrative response, was make your course hybrid. For the stuff that you say you don't have time for, you put it online, you post everything online, you have demand, and then you do assess it. And that was the response that we got on that. Make your course hybrid if you can't do it. And our argument was, when I started teaching at this university, I've been teaching for 35 years, we used to have 17 weeks in the semester, now we're down to 12 and a half. And I'm like, how do I keep teaching the same stuff? Make it hybrid. We're not gonna go back to the old days where you start before Labor Day and you end a week before Christmas. We are going to start after Labor Day and we're gonna end 2 to 3 weeks before Christmas. That's just what we're gonna do. And we're gonna take a whole week off in for Thanksgiving, when we only used to just take the Wednesday, Thursday, Friday, you know. So they have decided, we're shortening it, you make it hybrid. That was a response to that.
Yes.
I would like to know, we are switching to 7-week classes. I teach at a community college, so I would like to know if anyone here is teaching 7-week classes. Do you teach? Summer. No, like all of there, we get some exceptions, but they are telling us we have an awful, horrendous new president who has decided 7-week classes. Now, our physics classes have gotten a stay, thank goodness. So I don't have to teach calculus-based physics in 7 weeks. They have said, you have 7-week classes. That's it.
Do you have more semesters?
We do have more semesters, and astronomy is one of the ones that's on the block to eventually go to 7 weeks. And so it comes, and we don't get a finals week. You get centers to teach it. The astronomy lab, our astronomy lab is separate. They don't have to take the astronomy lab with the astronomy class. So it's a little separate. So it comes down to, and then they're like, okay, you don't have to adjust your course goals. You do have to adjust your course goals. Our school is a basket case right now, to say the least. Basket case is the nice way to say it. The other way is, I won't say in good company. So a lot of this comes down to that too. You know, what do you cover? You know, what do you cover is, what are we going to do? And so that's why being here is really interesting. How do we approach it? You know, are we teaching 3 hours? Are we teaching each class? And in a community college, how do you approach it? What can you cover? What can't you cover? You know, and luckily for us, it's all non-science majors, so it's not like it's stuff they have to know moving on. But that comes down to 12 weeks. So any of you who do teach 7-week classes, I would love to meet up with you and see how it's going and get your opinion. Maybe lunch or dinner later this week and have some interesting conversations.
I mean, that's a whole different question. You know, the question is, what content do we cut out to make room for investigation-driven approaches? Here, you just, what content do I cut out to make it to the end of the semester?
Yeah, and so, but I would also, but you know, and then the 3-hour classes versus the ones, and we have online versus not online too, so. And that's another question too, if you teach solely online, I don't know how many people in here, I'd also like to see a show of hands. How many of you teach solely online classes?
Well, but it's synchronous. Like there's
Well,
a
there's
big
synchronous
difference.
online and then there's purely online. Like we have hybrid, we have synchronous online, and then we have, and then asynchronous online
but
too.
there's
I don't know if we have
MOOCs
conversations about
versus-
this later on too.
Yeah.
So asynchronous online, synchronous online,
Synchronous online.
hybrid, in person. How do you get the different modalities to do? Can you do asynchronous investigations? How do you do asynchronous investigations?
I have lots of opinions on that, but I'll
These are all great questions too.
Yeah.
You
Yeah.
know, like how do you these different things, not just the content. So this is all great stuff. I mean, this
Yeah.
is why we all came here.
That's why we're here, for
so
sure.
anyway,
Yeah.
Well, you say you meet for 7 weeks, but how long are the classes? Like what cadence are your classes?
well, I don't, for the astronomy classes, I think they're supposed to be 3 hours long, but we don't get, they're 7 weeks including the finals. So it's not 7 weeks and then a finals week. It's just 7 weeks. And so like, there's a whole other stem of issues that go with it. Like what happens if a student gets sick for a week? That's it, they're done. They can't make up that work. What happens if I get sick for a week?
I mean, I teach astronomy in the summer sometimes, and it's 5 weeks, but it's 2 hours a day, every day of the week.
Yeah, so no, these would be like 3 hours twice a week, maybe. Which is a semester, but then usually that semester you get a finals week. So your final has to be squeezed in there somewhere too.
That's a semester.
It kind of is, it kind of isn't. Yeah, I mean, that's our argument.
One class for 3 weeks. They only take one class for 3 weeks. That's what they do.
Yeah. 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 Yeah, there's arguments for it.
It only works, I think, if the students are not doing their normal number of classes. Maybe.
Yeah.
Can I give a simple answer to the question? If we move toward investigation-driven approaches, what content are we getting rid of? Seasons and phases.
What
To
does it
elaborate,
mean?
and then I'll pass it to you.
I object.
They
What does it
learned it in
mean?
elementary school. They learned it in middle school. They learned it in high school.
All right. Wait. I've got a mic here. And
1,000 things
this,
to teach them that they would.
this is the debate between Sadler and Pasachoff from 2001. Back when we both started here in Chapel Hill, we were here, but this debate was happening in the physics teacher after a San Diego conference, and they got on the boxing gloves and all that, and debated exactly that. Put on the boxing gloves and say, do you get rid of seasons or not? I don't need to have that debate, although I would say they remember seeing things with their eyeballs through a telescope and not believing that it's real, and in this world, and I make them use the phones too, but in this world, when everything's digitally transmitted, them seeing nature and photons with their own eyeballs is relevant. Teaching them to appreciate sunsets is relevant. They're not clearly learning this in elementary school because they show up to college and they still don't know it. So I completely agree. Something that you said earlier about where the sausage is made and like at what point do they need to learn about dark current? Well, that's certainly later, but I would also say that even Skynet is something that they should learn after they've seen Jupiter with their eyeballs. Because otherwise, how are they going to know that what Saturn really looks like? They'll think that's something that can only be done online. But I want to bring us back to this slide because this went all the way around. This morning we all said that astronomy could be anything in the intro astronomy class, and we were all doing things. And so I was baffled by the comment you made over here because no one in 20 plus years at Elon has ever asked me, what is required for astronomy? And I get to teach whatever the heck I want in there. And I don't know, and let's go specifically with non-majors. What is required to keep in? Is there anything, like you're talking about what do we get rid of? I honestly don't know what's required to be in there because for the non-majors, you take the class and hopefully you're going to have a good life. And so that's a legitimate question. Like, what are they telling you has to be in your Astro 101 non-majors course? And I didn't hear an answer that we had. We were all saying different things. If we don't come up with an answer, who will?
For me, like I started teaching astronomy like one semester course where you go through the whole astronomy. And then recently I switched to teaching a 2-semester course where the first semester you focus on solar systems and then the second semester you focus on cosmology. And one of this question was I always had in mind when I was teaching the full load was like, what do I cut out, right? And so the one question I started asking myself is, if I were somebody who didn't know anything about astronomy, and if I look up in the sky and I see something, that is important to me, right? So phases of the moon is important because you see that thing every night. I want them to understand why they have the phases, eclipses. Seasons, because so I start my astronomy course by asking them to sit inside. Imagine you are inside Earth and observe everything you can observe, and can you make sense of it? Then after that, I take them outside the Earth and then try to look at the universe as a whole, like the solar system and things like that. So that kind of gives me a way to kind of cut down or maybe minimize how much time I spend on a particular topic based on its importance. But
Wait, I don't understand. What's the inside the Earth thing?
so for example, I try to track the historical development of astronomy because I think the student needs to understand this 1,000-year struggle that we had to try to understand the cosmos sitting inside Earth without telescope.
I see.
You see the stars going around, and then you question yourself, why are they going around? You see the retrograde motion, then you ask a question, why it is doing the retrograde? And so those kind of questions, I start with a question and try to answer each question, trying to build what the actual universe looks like and why it does the way it operates. And I only try to include the content that I can tell them with a reasonable explanation, not trying to sugarcoat it, give them a reason explanation, logical way of trying to understand it. If I can't do that, I try to get rid of the content.
Wow, cool.
I'd like to just do a different take on this question a little bit. And that is, one of the things we're doing at Road Observatory is creating these off-the-shelf investigations you can use that use authentic data, but that could be done in 2 hours or less. That was our golden rule, okay? So how do you do that, right? It gets back to what are you getting rid of? And I'm gonna say we're making mashed potatoes the way that most people do, not from scratch, right? So we're making the instant mashed potatoes. We're getting the rotisserie chicken at the supermarket instead of, going out and slaughtering a bird and starting. So, I mean, the whole point is you can do it by cutting out some of the detail that, and I'm speaking again for an intro astro student, not for the major track. Obviously, we can't do that. But cutting out some of the detail of how do you get the data, how do you curate the data, and then building inline tools like we're using here that are very simple with low learning curves that don't require an hour or more to learn. Okay, so one other way we could think about this is how can we make our classes a little bit less complicated for students? As an example, we have students work through mathematical expressions to get numbers for their data set, but we give them the online calculator built into the investigation. So we don't even teach them how to use a calculator. It's all built in for them. And they get the same end product without having to go through the steps that often frustrate them or derail them. So a broader way I'll put this question for all of us is what can we build in, what kind of scaffolding or supports can we build into our classes that eliminate some of the unnecessary sausage making procedures?
Time, yeah, okay, I'm not gonna beat you, Daryl. You got through 5. I'm only gonna get through.
You need 5. Go for it.
I'm gonna try, but oh, yes, this is one that's worth spending a bunch of time on. I was mentioning it earlier because I struggle so much with prereqs. As I mentioned, I teach 2 different classes, and I have one that doesn't have a physics prereq and one that does, and everyone wants to take the one that does, even if they haven't taken the physics, despite my ranting and railing about how it's like there's no reason to ruin your life, and this one's going to ruin your life because it's going to require lots and lots of time, and I'm going to test you on things that we don't talk about in class because they're part of the prereqs, and I want to skip to the other things, and they still do it. Every year I've sent a bunch of emails in the last week begging people to either take the prereq or take the other course that exists for them. Students, then it becomes, it's just a huge mess. I wonder how much other people deal with this and what the prereqs are even for your courses that, or particularly, I guess my own personal question is, what about the courses that have prereqs that students want to skip? How do you deal with those? And what happens to those students when they take your courses? Yes.
So I thought of a couple of things. One, so I'll speak to like the prereq thing, because for the physics class that I teach in the fall, it's for non-physicists and non-engineers. So I have a bunch of like chemists and biologists taking the class. And I was, minding my own business in my office, and I suddenly get a ton of emails wanting to waive our, because the math prereq for that class is, algebra and trig. And I was like, wait, they haven't, taken it already yet? And I was flabbergasted. And so many of my students hadn't really taken an AP test or something else to like prove that. And I'm like, I don't want you to waive this and then that being setting you up to fail in my class. And so the thing that me and one of my colleagues came up with in the biology department was we found some like practice tests for like the, not AP, but like SAT, ACT, that he was like, hey, I'm willing to administer this as like a to like show that, to give some sort of gauge, because we had been realizing that we couldn't necessarily trust that our students actually had the math skills for my physics class anymore. And that kind of hurt to see, but we finally had some sort of a solution.
So a placement assessment instrument.
Yeah, because that way there was an option and a more concrete way to tell, like, is this student ready for the math in my class or not? Now, as for astronomy, what I noticed was a lot of my students weren't the greatest at math. And I want to help them so that they don't flounder, but it's hard when you have a lot of students to help every single one. And so
yeah,
I would love,
individualized support, but then if you have lots of students, that becomes less practical.
Yeah, because in my astronomy class, I'm not expecting them to be able to do like derivatives or anything, but sometimes they don't know, like they're lacking in their math skills, or they just don't know how to use Excel or something like that. And or the one that I found out at the end of the semester was, but I'd had an inkling of throughout the semester, was their writing skills weren't great. They had to write something for an extra credit assignment, and one of the extra credit assignments was very, very disorganized, and just the way the flow of the ideas were. And I'm just like, how do I help these students, even though I don't have the time to help every single one, because I want to see them succeed.
Right. Well, this is a good segue, I think, to actually ask some of our panelists as well, particularly Imad, because you've had to have many different levels of coding come into your coding intensive class. And I think it's not an official prereq. Is that right?
Yeah, I mean, I think at Yale specifically, I think from having a small program, the prereq situation is also just sort of a mess globally. Classes that they have to take across the generally multiple majors that they're doing are sometimes only offered every 2 years. And so they're really just picking up the classes that they can when they can. And then they come into every individual class with not having been on any clear track that instructors can use to determine what they might know or not know. And they all have a very, very different mix. Which is a considerable challenge when you're trying to focus in a class on some higher level thing. And so, yeah, I mean, let's just say there's always a 2-week boot camp at the start of every class that's coding intensive, because regardless of what the prerequisite situation was, there will be people in the class that somehow have never seen code at all, or have seen code in such a spotty context that they know how to do 10 specific things, but not the fundamentals that are needed to approach the higher level classes.
Great. Yeah, thanks. Why don't we just go through the panelists, and then I see there's lots of hands. We're not going to get through more than 3 questions, I fear, but that's okay.
We're doing fine. We're going fast. We're eating the mic. Yeah. So, I mean, the first thing I wanted to say in response is that it's really important for us to understand what the function of our prerequisites are. And if we have good prerequisites for good reasons, we are not doing the students any favors by letting them into a course for which they are unqualified. And that's going to tank it for the other students. It's going to be a great time suck for you. So I think there's a lot of wisdom in knowing why you're saying no and telling them this is, is it in everybody's best interest? And we just need to be confident in that. We can feel bad, but then be confident in it. Turning to the question itself, when I think about my intro Astro course, I purposely have no prerequisites at all. And I've got multiple reasons for that, right? Like one is it's lab sciences are a requirement, so we're expected to serve all students. Another is that I want those first years. Come on, get them into my class, please, and we can see what we can do. And I had a third reason. The other is just the philosophical one, right? I mean, should be for everybody. Every citizen should have access to that kind of course and experience if they want it. So I'm all for that. But that said, same thing Deanna was saying, I've seen more and more students coming with a basic quantitative skill set that's lacking. And that I don't have time to go back and teach algebra. I don't have time to go back and teach trig. We'll review those steps once when we hit them the first time, but otherwise, there's not time to remediate. And so I've actually started to become explicit about things that I previously had to assume. And I've started to say, here are the tools that I trust or that I believe you've been exposed to and that I'm expecting you'll be able to use with moderate proficiency. If not, here are the links to Khan Academy, and I'll meet you outside of class. But you need to know, and I need to know, and that's how we go about it. For the upper level classes, though, I do think that the prerequisites are vital. I do tell, for my second level class, I say either you've had intro astro or you've had sophomore level atomic physics. So either you know about atoms and photons or you know something about astronomy, and then you know where your strengths are and you know where you can grow into.
What content knowledge do you assume students will have? There was a time when I assumed that students walking into my survey of astronomy class knew that the world is round. I no longer assume that. We go over the evidence on the first day.
Wow, yes. So I saw a lot of...
It directly follows on. It directly follows on. And this is a warning. This is a warning for all of us, because for the next 20 years, your students will be less prepared, like with even 4th grade math skills. The eye-opener I've seen lots of warnings, but the eye-opener for me was in the first minute of class, drawing this on the board as the gimme, and like, all right, kids, how many degrees is this? And none of them could answer. Is it 45? No, it's not 45. Is it 25? No, it's not 25. Is it 45? No, it's still not 45. All right, that was the first minute of class. At some point, we've had to start to create pre-calculus for the first time. And I've been able to teach intro astronomy, assuming nothing beforehand. But if your question is, there's a 90-degree angle between this and this, and they don't know what a 90-degree angle is, then look, they're lost. I would encourage you strongly, all of us, to think about a different sort of intro quiz so you know where they're coming in, that tests things all the way down to 4th grade, because this in North Carolina is taught in the 4th grade, and they don't know it. All of our diagnostic tests are like ADT and all that was all college level stuff. But between pandemic and the academic cliff, where there's fewer babies born, means that all of our schools are having to dip deeper into the well to pull students that aren't quite as prepared as they were 10 years ago. And so couple those two things, and we're going to see it very quickly for the next 10 to 20 years.
I was just going to say, related to that, at the Astro Codex on Friday, one of the groups was actually working on a exactly that kind of assessment that was a sort of choose your own adventure, in the sense that it would start asking you questions, and if you were getting questions right, it would move you on a track towards more advanced questions, and if you were getting questions wrong, it would move you on a different track, to try to like assess where your levels was. And I think that kind of thing may be particularly important moving forward.
So, as far as intro astronomy goes, can you all hear me?
Yeah.
Okay, good. Then what I found when I first started teaching was that my students would either come with a big preparation or a not very big preparation. And then by the end, the ones who already like paid attention and knew their algebra from high school, wow, they were doing great in my class. And those that didn't weren't. And I realized that I wasn't testing them on what I taught them. I was testing what they already knew. And and then I thought, well, what do I do? And then most people teach a qualitative, they say give up and they teach a qualitative course. And now you have a tour of the universe that is really nice and sweet, and you can justify that because your students are non-majors and therefore it doesn't really matter. Well, in my school, I'm expected to get physics majors by them taking astronomy first. So, you know, they come in, they take my class, and if they like it, they go on. And if I don't teach them the skills and they like it, they do poorly in physics. But if I teach them the skills along the way, they do well. So then I have this problem. Okay, I have all these skills that they need to learn. I've got this mix of students, some already have the skills and some don't. And I said, well, how do I solve that problem? And about 10, 15 years ago, I solved that problem by saying, well, what do we astronomers care about? And I said, well, we astronomers care about ratios. That's what we do. Everything in astronomy is a ratio. And then I realized that nobody knows ratios. The good math students don't know how to do ratios. The poor math students don't know how to do ratios, but they know anything else either. And they definitely don't know scaling. They don't know how to do ratios with a power. And so what I did was I said, okay, everything I teach is going to be a ratio, whatever it is. If I want them to use Newton's second law, I will not give them big G, but they will have something they're comparing it to, the mass of the Earth or something. And it's worked out well for me for the past 10 years. My students they come in with a whole variety of skills, and it's not the same ones that were the good students in algebra, especially the ones who memorize their algebra, as do well in my class by the end. At the beginning, they're scared to death. And so it's actually worked to encourage people to then move on to physics because they've done something that they perceive as really hard and they succeeded at it. So I would advise people in this type of thing to think about their math in terms of how can we teach a certain set of math skills that are really important. For me, it's ratios and computer skills with Excel or whatever your favorite spreadsheet is, and that's it. Bingo.
If I can follow on real quick, I think that concept can be generalized to beyond math backgrounds. You have students of all sorts of different backgrounds, some talented, some maybe not as well prepared, but very enthusiastic. You give them a task where none of them are familiar. Many of you know I take students to Green Bank Observatory for a week, and they could be excellent students, they could be not, but enthusiastic, but none of them know radio astronomy. I bring the educators, they don't know radio astronomy. And it's great for the students to see the educators struggling along with them. But whatever it is, you put them all together. That's important as a group, so they can bring all their different diverse backgrounds together. They don't all have to be good at math, as long as there's one good math person on the team. And you put them in a scenario that's unfamiliar for all of them, and great things happen.
Thank you. Talking about what previous content knowledge brings me back to when I was writing my dissertation. I was curious as to how much content knowledge students had before coming into the college environment. And I don't know about North Carolina, I'm from Indiana, but in Indiana, I had a Freedom of Information request done for teaching licenses. And in the state of Indiana, there are 533 high schools, and there are only, hold on, I gotta do math, 224 calculus teachers, and there are only 137 physics teachers there in Indiana. And there was a disparity in algebra as well. So like your students may not actually be behind because they're not good at it. They might be behind because they didn't have access to that information. And not only that, a lot of the teachers that were on the Freedom of Information request that I had weren't even licensed in the content they were teaching. Their primary license was in something else, and they got dragged into teaching that. And so it's really important to remember that not only is that one state example, but as college professors, we'll get students from literally the whole country, maybe internationally as well. So these dips we see, it may not be because they're not capable, it's just because they didn't have access to it. I also, unfortunately, know several elementary teachers in my state that don't teach science in elementary at all because of their perceived importance of literacy and math. So they don't even teach the planets and all that. So there's a lot of disparity in how students come to your classroom that is more than just what they're capable of.
That's so important. Yeah.
Will not include this year's 7th graders going to.
Oh, wow.
So this year's 7th graders do not need Algebra 2 to graduate high school. So the math is going to be just Algebra 1 and geometry.
Oh, wow.
When they're going into college. And that's Indiana, but it's probably going to be other states as well. Because they're really pushing.
Wow, these are important things to remember.
Hello. On that note, I would never have assumed any of my students have any Algebra 2 knowledge. They've all taken it. It's required in Washington State. And the students who know how to do that do it. But so many of my students haven't taken math in years, I wouldn't assume that the Algebra 2 would make a big difference to my class. So I would not assume that as a prereq.
Can get you in.
Yeah, in light of the comment about people not having access to a lot of prerequisite knowledge, I wanted to come back to the idea of doing an assessment, like a math skills assessment at the beginning of the semester. I know some folks were suggesting that, and I, in general, agree that that's a good idea. This is something I tried last semester when I taught intro astronomy to non-majors for the first time, and I did like a math skills assessment for the skills that were going to be needed just for the class, which involved, you know, algebra and like reading graphs, basically. And one issue I ran into is it actually having that up front seemed to put a lot of students off and just kind of like shut them down for the entire semester. Right? I had a student come to me struggling with one of the algebra problems, saying, well, how am I supposed to do this? I never learned calculus. And I was like, okay, so there's like a huge disconnect, right? Like not even knowing that it's algebra. And with that experience, I kind of moved away. I think this is something I'm still like debating in my head, but I feel like maybe the just-in-time approach is better than the pre-semester assessment, because I think I did lose a number of students in that first week just because they gave up immediately. So that's something, I don't know, I just want to think about when we talk about the idea of like the assessment up front.
Oh, definitely. Thank you.
When I was teaching astronomy, I had the same issue. Like I talk to students, they have no idea how to move decimal points over because we use scientific notation a lot, right? They had no idea how to move the decimal over or do fractions, right? So what I started doing was I tried to focus just on the math and give them a math review at the beginning of the semester. But again, the problem was since this math would be disconnected from the astral astronomy, they were more afraid from the content than trying to learn math. So what I've started doing now is that like the first 2 weeks, we just go over scale of the universe, powers of 10, and I do whole review of the math and the fraction by comparing sizes and things like that. And I think it has made the students a little bit more into the content just because it's geared towards astronomy discussion instead of just a purely math discussion, which they are more afraid of. And the other thing that I was trying to talk about is I think I completely slipped my mind. Yeah, so students are afraid of equation, right? So what has happened in astronomy and generally in science is like we are gearing towards like more moving away from equations and trying to give them the content without equation. And I think we are short-circuiting this process of where students are thinking about the equation and what it actually means. So what I've tried to implement now in both physics and astronomy is like I have moved away from math, but in a sense, like I make them read the equation. So when I first put the equation force equals ma in the class, I want to move through all the iterations of changing each variable and saying like, if I increase the mass, what happens to the force? If I increase the acceleration, what happens to the force? If I increase the force, what happens to the mass that I can move? So I go through all these iterations, and always in exam, I have a question that they go through the pulley problem, for example. At the end, there will be a question where it says, if I increase the mass, what happens to the acceleration value that you have obtained? So they have to go through the whole equation and try to think about logically what happened at each step. So it has helped anyway. So.
That's awesome. So I think we covered some of these other questions. Where's Dan? I want to take credit for some of these other questions getting covered. We talked about, well, I guess we didn't talk about this one at all. But we talked about ChatGPT. We definitely, I think, the answer to this question is embedded in some of the discussions that we've had already. We didn't talk about assessment, which is a whole other thing, but we talked about ChatGPT. I'm taking credit for having done more questions because, because we embedded some of them, some answers to some of them in our responses to others. We have only 7 minutes left, and I think we're even behind. And as I was hearing all of these thoughts, one thing that was going through my mind is that I was wishing that I was in a place where I could take notes more easily. And so I was wondering if we could use maybe a few of these last 7 minutes to have everyone who said something, and even anyone who didn't, post something in the Discord that kind of captures what you said about something or something that you heard that resonated with you. And if we could have at least some of those thoughts captured, then maybe it'll be okay even that I wasn't taking notes for this time, because we're going to have to assemble all these thoughts to write them up. And right now they're all churning madly and wildly and chaotically in the back of my brain. So would that be okay? Would that be a good use of time, just for a couple minutes, write down some thoughts?
In the Discord.
In the Discord, under the content strand, anything that you heard, anything that you said, anything that would be worth capturing or thinking about. It would be great if we could do that. Sure. And then we'll, I think next on our, and then we'll break. And then right after that on our agenda, we have Rob Zellum coming in remotely to do exoplanets. So great. What time is Rob going to come in?
Right after break.
Right after break.
About 20 So
20 minutes.
Notes, 20 minutes of break.
Perfect. That sounds
But you
great.
don't earn your break snacks unless you write.
Yeah,
5 minutes.
write something and then go get a snack. That's your reward. Thank you all so much. This was illuminating.